Welcome, ladies and gentlemen, to the beginning of trigonometry. Today we are going to learn about sine, cosine, and tangent. So we first should probably talk about, well, what is trigonometry? A trigonometric ratio is a ratio of sides in a right triangle. There's three ratios. You could see them in the title. Sine, which we normally abbreviate SIN. Cosine, which is abbreviated COS. And then tangent, which is abbreviated TAN. So, the acronym to remember these is SOHCAHTOA. So sine is the so part here. Sine, O stands for opposite, and H stands for hypotenuse. So in our triangle, the side opposite of C is AB, and then the hypotenuse is AC because it's across from the right angle. Normally we would have numbers there, but right now we're just using sides. Cosine is the ca part, so C stands for cosine, A stands for adjacent, and then H again stands for hypotenuse. The adjacent side is the side touching the angle, but it's not the hypotenuse. So in this case, AC is touching angle C, but that's the hypotenuse. Therefore, the adjacent side is BC. And then we already said the hypotenuse is AC. And last one is tangent. Tangent goes with the TOA part. T stands for tangent. O stands for opposite. And A stands for adjacent. Again, the side that is opposite of C is AB. The side that is adjacent to angle C is BC. So again, normally you're going to have numbers for these ratios, like 1/2, 3/4. But right now we're just using sides. So let's look at example 2. It says, find the ratios listed below. I'm going to do angles K, or angle K. I'm going to do the three ratios, and you're going to do angle J. So starting with K, sine, that's right up here. The acronym is SOHCAHTOA. So sine is opposite over hypotenuse. That's what the SO is. The opposite side is 32. The hypotenuse is 40. So my ratio is 32/40, but I have to simplify that. Both are divisible by 8. So this becomes 4/5. Cosine goes with the ca. That's adjacent over hypotenuse. Adjacent side is the side next to the K. That's not the hypotenuse. So in this case, it's right here, it's 24. And then the hypotenuse is 40. Same hypotenuse from above. Again, both are divisible by 8, so this becomes 3/5. Last one is tangent. Tangent goes with the TOA part. That's opposite over adjacent. Opposite side is still 32. The adjacent side is still 24. Both are divisible by 8. So this becomes 4/3. Take a minute, pause the video, and you do the sine, cosine, and tangent of angle J this time. So this time pay attention to this angle. Good luck. Okay, let's see how we did. Sine of J should have been opposite over hypotenuse, which is 24/40, which simplifies to 3/5. Cosine of J should have been adjacent over hypotenuse, which in this case is 32/40, simplifies to 4/5. And then last one, tangent of J should have been opposite over adjacent, which is 24/32, which simplifies to 3/4. So, hopefully that one went well for you. If not, you will get a chance to redeem yourself. I want to talk about a few properties. First one, sine is always between 0 and 1. So it's always going to be a decimal between 0 and 1, or a fraction. Cosine is also always between 0 and 1. And this should be true if we look up above. 4/5, 3/5, 3/5, 4/5, all between 0 and 1. Tangent is the only outsider. Tangent is greater than 1. That's all we can say. Tangent can be a fraction between 0 and 1, or it can be greater than 1. In one case, we have 4/3. That's bigger than 1. In the other case, 3/4. Greater than 0, but less than 1. So this is a way to check your answer. If you get a sine or a cosine ratio that's greater than 1, you did something wrong. Last thing I want to point out to you, which you may or may not have noticed above, is the sine of angle K was the same as the cosine of angle J. They're both 4/5, and then the cosine of K was the same as the sine of J. This is always going to be the case. The sine of one angle is going to be the cosine of the other angle in the same triangle. So the sine of K is the same as the cosine of the other angle J, and vice versa. The cosine of K is the same as the sine of J in the same triangle, the other angle. And then the tangents are reciprocals. So 4/3, the reciprocal, will give us 3/4. Again, this is a way to check your answer. So let's use these facts to do another problem. Flip the page, please. Okay, so you will notice that you have a worksheet that says Finding Trig Ratios classwork. This is classwork, but we're still going to do a few of them together. So looking at the first one, sine of x is opposite over hypotenuse. So I'm going to write SOHCAHTOA at the top. Okay, opposite of x is 3, and the hypotenuse is 5. Cosine is adjacent over hypotenuse. The adjacent side is 4, the hypotenuse is 5. Tangent is opposite over adjacent. The opposite side is 3, the adjacent side is 4. Now, for z, sine of z is opposite over hypotenuse, which is 4/5. Cosine of z is adjacent over hypotenuse, or 3/5. And then tangent is opposite over adjacent. Opposite is 4, adjacent is 3. Now, to check our answers, are our sines and cosines between 0 and 1? Well, we have 3/5, 4/5, 3/5. Sorry, I underlined the wrong one. 4/5 and 3/5. All between 0 and 1, that's good. And then, sine of one angle is the same as the cosine of the other. Cosine goes with sine. So good. And then the tangents should have been reciprocals, which they were. So, pause the video and try this example right here on your own. Good luck. Okay, let's see how we did. Sine of x should have been opposite over hypotenuse. Opposite is 7, hypotenuse is root 149. Cosine is adjacent over hypotenuse, or 10 divided by root 149. Tangent is opposite over adjacent, or 7 over 10. Sine of z is opposite over hypotenuse, 10 over root 149. Cosine is adjacent over hypotenuse, or 7 over root 149. Tangent is opposite over adjacent, or 10 over 7. Doing our little mental check. Sine matched up with cosine, cosine matched up with sine, and then the tangents were reciprocals. So that's good. Again, please find all 6 separately and then check your answer. I've had students in the past who find the sine of x and then immediately write it for the cosine of z. Yeah, that's true, but if you find the sine of x wrong, then you're going to get 2 questions wrong, which is silly. So hopefully that one went well for you. This is your last question to do right here. When you come to class tomorrow, I will be checking to see that it is done. Please make sure that you reduce your fractions. If you need one more example, just to make sure you solidify your understanding, I'm going to be doing this next example with you. If you don't want to follow along, that's fine, but please make sure that you have the problem above that I starred completed when you come to class tomorrow. If you do not have the problem completed, you will not get full credit. So we're going to do this next one if you need one more practice. We're going to start by finding x, so we need to use the Pythagorean theorem. I have 12 squared, add 16 squared equals x squared. X is the hypotenuse because it's across from the right angle. This gives me 144 plus 256 equals x squared. So 400 equals x squared, and x equals 20. And then I'm going to put that in my figure. And now I'm ready to go. Sine, if we remember SOHCAHTOA, is opposite over hypotenuse. Opposite of A is 16. The hypotenuse is 20. Both are divisible by 4, so this becomes 4/5. Cosine is adjacent over hypotenuse. Well, I know that 16 was opposite, 20 was the hypotenuse, so 12 has to be the adjacent side. It's touching A, but it's not the hypotenuse. So cosine is adjacent over hypotenuse, so it's going to be 12 over 20. Both are divisible by 4 again, so this becomes 3/5. Tangent of A is opposite over adjacent. Opposite is 16, adjacent is 12, because remember it can't be the hypotenuse. Dividing by 4, I get 4/3. Sine of B, opposite over hypotenuse. Opposite of B is 12. Hypotenuse is still 20, so this simplifies to 3/5 if I divide both numerator and denominator by 4. Cosine of B is adjacent over hypotenuse. I know that 12 is the opposite, 20 is the hypotenuse, so 16 must be my adjacent. So it becomes 16 over 20. Dividing both by 4, this simplifies to 4/5. Tangent of B is opposite over adjacent. Opposite of B is 12. 20 is the hypotenuse, so therefore 16 has to be adjacent. This simplifies to 3/5. Now doing our mental check, we need to check are our sines and cosines between 0 and 1. Well, I have 4/5, 3/5, 3/5, 4/5. Between 0 and 1, so that's good. The sine of A should match up with the cosine of B, which it does. In other words, they should be the same. The cosine of A and the sine of B should be the same, and they are. And then the tangents should be reciprocals. Ooh, they're not. So if we look back, we notice I made a mistake on tangent of B. Instead of 3/5, it should be 3/4. 16 divided by 4 is 4. So now they do match up. So it's a good thing I checked my answer. Hopefully that gave you enough information. Please go back and do the starred problem at the top for class tomorrow. Again, make sure that you simplify your fractions. Good luck.